Hello guys and welcome. I hope that you're doing well. My name is UHD King, or I play 4K, AK, I play 8K, AK, I play 16K, and during this video I'm going to demonstrate the world's record while running Batman Arkham Knight game in 16K video resolution. 16K gameplay, 16K gaming, 16K video resolution benchmark. To be exact, 16K UHD video resolution, 16 divided by 9 aspect ratio. Throughout this video, I'm going to demonstrate all kind of different visual presets. So if you into 16K UHD gaming, this is the best video for you to watch. This video is not going to be as fast as possible. This video will be around 1 hour plus, but I'm going to share all kind of information, all kind of details, all kind of knowledge. So if you're trying to play games in 16K video resolution, this video will be a great video to watch. Or if you're Batman Arkham Knight game fan, this is an amazing video to watch. Or if you're into Nvidia GPUs or Intel CPUs, this is a great video for you to watch, no matter what kind of industry you came. Graphics designer, 3D artist and 3D animator, a game developer, software developer, PC hardware enthusiast, PC overclocker, gamer, a lot of system engineer. A lot of information will be shared, or PC hardware engineer as well. So you will have a clue what do you need and how to build 16K UHD gaming system. Alright guys, so before I'm going to run the Batman Arkham Knight game on Steam, let me introduce you to my system. Let me show to some naysayers and to some people who is curious some facts. So first of all, today I'm running Intel i9 9900K overclock at 5.1 GHz and the Titan RTX video card that is equipped with the 24 GB of video RAM. It's going to be a flagship video card of Nvidia Turing GPU architecture, that is Nvidia TU102 GPU. Okay, so I'm running i9 9 Gen Intel CPU 9900K without hyper-threading technology, so only 8 physical cores, 8 physical threads, but running exactly 5100 MHz or 5.1 GHz per every single core. I disabled the hyper-threading logical threads because when it comes to Intel 9 Gen CPUs, 2.7 logical thread through the hyper-threading technology is equal 1 physical thread. So this is how slow they are. Keep that in mind. By the way, the audio track is all rights reserved. There is no royalty can be claimed. It's White Hats by Wayne Jones. Okay, provided by YouTube. All rights reserved. No royalties can be claimed at any time. So let me, as you can see, I'm using the magnifier, Windows magnifier zoom tool. This is 700%, 800%, 900%. The reason why, because my desktop is set to 16K video resolution as well. The desktop itself set to 15,360 by 8,640. Let me zoom into 1600%. Let me see, is this, yeah, magnifier 1600%. 15,360 times 8,640. By the way, I'm owning, guys, the project about 16K UHD video resolution, 16K UHD gameplays, 15,360 times 8,640.com. Go ahead and check it out. 100% scale. Okay. Also, let me real quick go ahead and show you the Nvidia driver for those naysayers. But before I'm going to show you the Nvidia driver, let me show you how the AIDA64 GPU benchmark scored. GPU versus the CPU. I'm only running single Titan RTX in this Mozilla PC version 5.3. Even if I built Mozilla PC version 5.3 RR with the 2 Titan RTX in two-way SLI, but only single Titan RTX is installed to avoid any hot air pocket, because right now we are benchmarking in 16K video resolution in Batman Arkham Knight game single Titan RTX video card to find out, because because Titan RTX pretty much is a flagship of the RTX 20 series video cards, the first generation of the RTX video cards by Nvidia. It's a flagship, the top end. Okay, and we want to find out, and in our case it's the first video card that allow us to run 16K video resolution in Batman Arkham Knight PC game. All kind of different visual presets. Alright, this is the ADA 64 cache memory benchmark before 45 nanoseconds. NS stands for the nanoseconds. The lower value is better. Everything else, the higher value is better, such as megabytes per second, higher value is better. Okay, gigabytes per second, higher value is better. Okay, and let me show you CPU Z. So 5100 megahertz, 8 physical cores, 8 physical threads, but it's better than i7-9700K because 16 megabytes level 3rd cache. Motherboard Z390 chipset, Asus Maximus here 11 series, but Titan RTX running PCI Express 3.0 at 8 lanes. I cannot run it at 16 lanes even if motherboard supported by the manual, but I tried two different Titan RTXs that I have. It's not enabling 16x even if single Titan RTX video card is installed. All the slots are empty and there is no M.2 SSD installed. Still 8x. I had the same issue with the Asus Maximus here 10 series Z370 with the 8 series 8 generation of the Intel CPUs, like 8600K, and the same thing with the 9900K 9 gen Intel CPUs. Alright, so memory will be the fastest, probably the fastest possible DDR4 1600 megahertz internal frequency times 2 3200 megahertz external frequency. CL, not CL16, not CL14, CL11. The low value is better. 1T command. 4 sticks, 8 gigabytes, total 32 gigabytes. DDR4 running in dual channel, 128-bit, but 4 sticks can be set up in quad channel, 256-bit, but Z390 chipset motherboards doesn't support quad channel, only dual channel, 128-bit. But if you're gonna install 4 sticks, same sticks, it's going to deliver on a dual channel the maximum possible bandwidth because it's ready for the quad channel. It's ready for double bandwidth, keep that in mind. Cache frequency on the CPU 48 multiplier, which also decrease the latency on a level 1, level 2, and level 3 cache, and it's generating 4800 megahertz or 4.8 gigahertz, just a cache frequency, okay, of the level 3rd cache, keep that in mind. This is the fastest possible DDR4 because it's one of the fastest. This is DDR4 5000 megahertz, 2500 times 2, 5000 megahertz, CL18, but unstable on this type of motherboard, which is Z390 chipset motherboard, I believe. Why? Because it's a Micron technology chips, and when it comes to DDR4, Micron technology chips doesn't like the high frequency but allows the low latency. As again, low latency is better than high latency, but high frequency is better than low frequency. If you want to go high frequency in terms of the DDR4, I advise you to get Samsung B chips. But this is Micron technology chips. I believe Corsair lied to me about this memory, but we're going to find out if actually memory is supporting DDR4 5000 megahertz at CL18. Corsair told me it's only supporting on the motherboard as MSI Z390 Carbon Deluxe or Extreme, whatever it was, Carbon series. Okay, I have some doubts about it, but we're going to find out because I'm going to try to use it on a Z690 or a Z690 with the DDR4 or Z790 with DDR4 slots and with the 13 or 14 gen CPUs. So we're going to find out if it's pushable or not, because the Z690 chipset supports way above 5000 megahertz DDR4 support natively, keep that in mind. Alright, so Titan RTX right now running stuck. I'm about to overclock it, okay, through the MSI Afterburner. Actually, it's already overclocked. Actually, let me bring it to stock real quick, and just to show you a difference when it's stuck, when it's not stuck. So when Titan RTX is stuck, pixel free rate 169.9 gigapixels, textual free rate 509 gigatexels, and bandwidth 672 gigabytes per second, exactly as Nvidia stated. My bandwidth almost faster than level second cache on my CPU. Check it out. Level second cache on my CPU is 766 gigabytes per second maximum value, and this is one of the fastest caches. The fastest cache will be level 1 on the CPU or GPU, level 2 a little bit slower, and level 3 it's a little bit slower than level 2 before the communication with the system RAM when it comes to CPU. And my GPU only have level 1 cache and level 2 cache. It doesn't have on the GPU level 3 cache. But check it out, when I'm going to overclock my video RAM will be much faster in terms of the bandwidth than my level 2 cache on my CPU. This is unbelievable. This is how faster the video card versus the GPU and video RAM versus the CPU and system RAM. Alright, 1600% a little bit pixelated. This is 1600% on a magnifier zoom tool. Let me go ahead and bring it to 1000. This was for the people who is with the phones and tablets and iPads. Alright, so right now I'm going to go ahead and overclock it, and we're ready. Let me overclock it. Keep in mind that I'm recording this video as a single take. I'm not going to edit this video. Artificial intelligence removing some noise out of my voice because I'm sitting by the open case, and the dual fan design on Titan RTX when running 100% is very noisy. So artificial intelligence removing that noise. Keep that in mind. Alright, so my voice can be a little bit disturbed. There is nothing wrong with my voice. Alright. This is the Nvidia driver right here, 536.67. So we overclocked the Titan RTX. Pixel free rate increased by 7 gigapixels per second. Textual free rate by 30 gigatexels per second, which is amazing. This is through the GPU overclock, those two values. And bandwidth through the video RAM overclock increased from 672 gigabytes per second to 786 gigabytes per second, as fast as on our RTX 30 series video cards that using GDDR6, because on the RTX 20 series video cards, and Titan RTX is a flagship of the RTX 20 series video cards and faster than RTX 2080 Ti video card, because Titan RTX has 256 CUDA core more of Turing GPU architecture than RTX 2080 Ti video card. This is unbelievable, guys. So we're matching the GDDR6 of the RTX 30 series, which is upgraded version of the GDDR6, but top of the line, top dog flagship of the RTX 30 series using GDDR6X, which is above 1 terabyte or 1000 gigabytes per second. Okay, but today is about RTX 20 series flagship Titan RTX, because this is the first video card that is allowing us to run Batman Arkham Knight in 16K UHD video resolution. And this system that I built, my Mozilla PC version 5.3 with the i9-9900K and Titan RTX video card, was available all the way back in 2018. So I could record this all the way back in 2018, but I was busy while recording all kind of 16K video resolution benchmarks, 16K video resolution gameplays in all kind of games. But right now it's time for the Batman Arkham Knight. Before the 2024. By the way, today is, let me show it to you. Today is almost 2024. Today is December 30th, 2023, 1:20 p.m. guys. All right. So Christmas is over, 2023, and we about in one day we're about to celebrate the new year 2024, and I'm going to wrap it up because I covered all Batman series, all 4 games from a third person view in 16K video resolution on the i9-9900K and Titan RTX video card, the setup that allow us to run those games for the first time. There is nothing else before those parts was available, so you can build the computers in 2018, was able to run 16K video resolution in all Batman Arkham City, Arkham Knight, Arkham Origin, and Arkham Asylum. Alright, so this one is covered. Let me real quick go ahead and open up the Nvidia driver for the naysayers and demonstrate real quick one more thing. And then I'm also going to demonstrate for you real quick why 16K video resolution is the maximum video resolution in 3D canvas, 3D world, 3D surface. It's called differently, depends what kind of open source or commercial 3D real-time rendering API that you're using in your games or in your applications. But this is, guys, the deal. Single Titan RTX is installed only. Secondary Titan RTX is removed to avoid any hot air pocket. Keep that in mind. So the fastest possible scenario for the single Titan RTX right now. The driver is modified or hacked to be able to emulate as good as native 16K UHD video resolution and output to 8K UHD. But this is not DLSS. This is not the upscale. Keep that in mind. This is rendering native pixels, as you can see right over here. Actually, it's a DSR, but Nvidia doesn't know it's DSR Nvidia driver, and I think it's native, as well as Windows 10 Professional Operating System by Microsoft that I'm running today, thinking that this is 16K UHD video resolution screen itself. Maximum performance, as you can see, so maximum performance will be available to us. This is actually my resolution today. Let me show it to you. Okay. 15,360 by 8,640, as you can see, by the Nvidia driver. Okay, registered with the Nvidia driver, and everything registered like that. Let me real quick go ahead and open the AIDA 64 real quick, just to demonstrate for you that 16K video resolution indeed is maximum resolution. And let me show you. This is the CPU, as you can see. This is my CPU that I'm using today for those who's curious. Okay, this is the CPU ID. As you can see, only 8 cores and 51 multiplier per every single core. Alright, and let me real quick go ahead and show you the Vulkan API. 16K video resolution is the maximum video resolution, XYZ. 16,384 pixels, XYZ. So it's 1000 pixels more than I'm running right now, because right now I'm running 16K UHD, which is 16 divided by 9 aspect ratio, and this one 16K video resolution is not 16 divided by 9 aspect ratio, different aspect ratio, but a squarish kind of aspect ratio. 32K video resolution, 32,000 pixels can be for 2D. If you are a great programmer, you can actually create your own 3D game engine and create actually 32,000 pixels XYZ, but it's not going to be XYZ, but you can kind of emulate XYZ. But people using already pre-built classes and functions and methods, depends what kind of 3D real-time rendering API that you're using. So it's set up for 16,384 pixels XYZ in all kind of as 3D world, 3D canvas, 3D surface. It depends how it's called under that API. So keep that in mind. Developers will understand, and I explained it to you guys, and you should understand it as well. This is OpenGL. So we saw the Vulkan. This is OpenGL, the same deal. XYZ 16,384 pixels. Y2D 32,000 pixels. All right. One thing is that CUDA actually is dominant here. 16K video resolution, which will be 16,384 XYZ. Okay, but on the 2D it can render 131,000 width and 65,000 height. So CUDA is actually dominant when it comes to 2D render, because CUDA is by the Nvidia, and Nvidia developed the video card, and it knows exactly how to render the pixels correctly. Alright, keep in mind that this data pulled up through the DLL, and it's maximum data, maximum what DLL supports. Okay, 16K video resolution, 3D surface, under CUDA called 3D surface. OpenCL, another open source 3D real-time rendering API. 16,384 pixels XYZ and 32,000 pixels 2D. Alright. What else do you want to see? Let me show you the DirectX. DirectX 16,384 pixels as well. Okay, so same deal. It's showing 11.1 DirectX because I'm running Windows 10 Professional Operating System, and it's using as a canvas of rendering background using DirectX. Actually, I believe since 2018 or 2020. It's fully DirectX without any 2D classes under Windows 10 professional operating system, but Windows 11 operating system will be using DirectX 12. Keep that in mind. And it's pulling through the classes, but DirectX 12 API will be just the same, guys. There is no such a difference. There is only multiple GPU capability enabled there as well, while the DirectX 11 API doesn't have multiple GPU capability. You gotta create it yourself, or you can use SLI or Crossfire or SLI. Nvidia SLI technology supported DirectX 9, DirectX 10, DirectX 11 API, but not supported on the DirectX 12 API. Alright, so by the way, Batman Arkham Knight Nvidia SLI is supported, so hopefully I'm going to demonstrate it for you. Alright, so this part is demonstrated. Let's go ahead and execute the game. So we're going to start with the lowest possible visual preset. Keep that in mind, and I'm going to get up after that and move forward to the higher visual presets. So you're going to see the difference in terms of the FPS data that will be displayed for you, as well as visuals itself. Please watch this video in 8K UHD. Switch your YouTube player to 8K UHD for the maximum visual experience, or 4K UHD as the minimum visual experience. I advise you to watch this video, otherwise 1080p you're not gonna see any difference. Alright guys? Okay, it's loading pretty slow, 3 FPS average. 16K video resolution already set, and it's running windowed borderless mode, because under 16K UHD it has flickering shaders a little bit under full screen, but Windows borderless or window bordered, it's fine. So let me show you the options, guys. This game has built-in benchmark, so we're going to use built-in benchmark. Good job by the game developers. If you develop a game, you always want to include the benchmark. This is a proper game development, so people can use your game and receive multiple values, not only playing your game but testing the hardware. They can buy your game just to test the hardware. This game is running Unreal Game Engine, keep that in mind. So it says the resolution 640 by 480, but it's not. The reason why it is because it's running the Unreal Engine that pretty much artificial locked to 10K video resolution, and after 10K video resolution it's going to switch to 640 by 480. Same thing as Batman Arkham Origin. I already explained it throughout the video. Batman Arkham Origin in 16K UHD video resolution benchmark. Go ahead and check it out over the UHDking.com. But anyway, lowest possible visual preset, you're gonna see what is 640 by 480. In the end of this video I'm gonna include it as a bonus just to test my CPU capabilities, so we can see how well the CPU tested, so in the future versus the different CPUs, just for those people who's curious about CPU performance. Okay, so lowest visual preset, Nvidia GameWorks settings is off. Okay, we're not gonna enable Nvidia GameWorks settings because when I'm running on Titan RTX and recording with Nvidia Shadow Play with this driver, I cannot enable Nvidia GameWorks settings, or if it is enabled, when I'm running the game, when I'm loading the benchmark, when it's loading the 3D world with the characters and everything in the game, it's just crashing with an error. Go ahead and check out my Batman Arkham Knight in 8K UHD on the Titan RTX, or Batman Arkham Knight in 4K UHD on the Titan RTX. You're gonna find out. So Nvidia Shadow Play is pretty much not compatible with the GameWorks settings under Titan RTX and this type of driver that I'm using today. Alright, so this is going to be the lowest possible visual preset. Okay, don't worry about 640 by 480, as again it's going to be 15360 by 8640. And to eliminate that artificial lock, you gotta go in the XML file of the graphics settings on the game and change it. I'm gonna show you to you actually on how to do it, and every single procedure I'm gonna show you throughout this video. Alright guys, so yeah, so I'm going to go ahead and click escape button. Do you want to save it? I'm going to say no, because it's going to apply the 640 by 480. It's already applied the 15,000 at 360 by 8640 with this lowest possible visual preset. I don't want to save and do anything like that because game engine doesn't understand 16K UHD video resolution, so it's switching to the lowest video resolution, and you can apply it, but on the graphics XML file on this game, for this game, it's loading actually 15,360 times 8640 pixels, which is, by the way, 132.7 megapixels rendered in real time. Unbelievable, guys. Alright, PC performance test is going to be built-in benchmark, which is great. And it's running it, guys. I'm going to refresh my average FPS with the short key. Here we go. And keep your eye at the left top corner. I'm sipping some Swiss hot chocolate, and hopefully you're sipping some nice healthy drink. Water, or water with the lemon is the best. Also tea with the lemon, or coffee will be good as well. Coffee with the honey. Do not drink any alcohol. Alcohol is pretty bad for you. Look how beautiful it is. It's running on lowest visual preset, but it already looks like 4K UHD at the maximum visual preset, but without the Nvidia GameWorks. Nvidia GameWorks will create the smoke coming out, and when model is running, 3D model, 3D character is running, it's going to go around that model like in real life. While without the GameWorks, it doesn't do it. So it's going to use the Nvidia physics capabilities, and it's going to create the debris, extra debris when you're shooting into walls and such, and extra smoke, extra abilities, which is great. Additional elements, additional pixels through the particles, accelerated by the Nvidia GPU only. So that's option only works for the Nvidia GPU only. We're not gonna test it throughout this benchmark anyways. So 10 FPS average, that's a great result. 132.7 megapixels for a single video card. This is going to be a second scene in the benchmark. Look how beautiful everything is. We increase in terms of the FPS. Right now textures are at low. I decided to show it to you, the video RAM utilization and etc. So you want to run 16K UHD video resolution texture at low. You want to set texture to the maximum, of course, but we're about to do it, so I'm gonna test all kind of visual presets. Look how detailed it is. This is even at lowest possible textures. Look at this piece of asphalt is right here, and it's not artificially blurred out like in 4K UHD. To see the difference between 4K UHD and 16K UHD, or 8K UHD and 16K UHD, please go ahead and check out my Crysis 2 in 16K UHD on the Titan RTX video card. Go ahead and check it out. That video available over the UHDking.com. I'm going to show you the details and zoom in, zoom out. We're not going to do it over this video. This video will be benchmark, but I'm going to go over and summarize it for you. 10 FPS, not bad. Average, not bad. 10, 11 FPS. And keep in mind that I'm recording with Nvidia Shadow Play. That is modified or hacked, and it's capable to record in 8K UHD video resolution. So please watch this video at least on 8K UHD, guys, for the maximum visual experience, or minimum 4K UHD. But Nvidia Shadow Play and Nvidia Turing GPU architecture is actually capable to record in 8K UHD, even in Nvidia white papers. But Nvidia didn't unlock this capability. I believe they decided to introduce this capability with the RTX 40 series video cards. Well, they introduced the AV1 codec, so people will buy the RTX 40 series video cards. But anyways, it's capable, and even Nvidia stated so in their white papers, and you can modify and unlock it. Anyways, guys, minimum 8, maximum 15, average 10, exactly what we saw. This is the minimum visual preset, everything at minimum. Alright, we're done with that. So what I'm gonna do now, I'm going to set the visual preset now to the everything will be normal, but not the maximum. Let me demonstrate to you the normal as well, just because this is the world's first video of 16K UHD video resolution in Batman Arkham Knight game. I decided to go ahead and provide you all possible information and all possible data. So this video is not as fast as possible, but as informative as possible. Goal to be as informative as possible. Alright guys, so this is how we're gonna do it now. Increase on shadows, textures, but not to the maximum level of details, and I'm gonna save it. I didn't put any anti-aliasing. I don't like chromatic aberration, especially when the FPS is below 20. Film grade, no. Textual filtering will increase later on, and including the anti-aliasing. So let's go ahead and save that. I'm going to go ahead and apply that. I'm going to click apply, and I'm going to also apply the resolution, this ugly resolution. Let me go ahead and apply that. I'm going to click yes. It's going to apply the 640 by 480 resolution, and you're going to see how ugly that resolution looks like. So it's going to say, do you want to save it? And what I'm going to say, keep the settings. I'm going to say yes. Let me show it to you. Because I want to save the settings. Oops, I was too late. So now it's gonna back to my settings, which is 16K video resolution in the graphics XML file. I'm gonna do it again. Sorry about that, guys. The FPS is so low, and it's kinda, my mouse was slow. Let me go ahead and do it faster. I was holding the cup in the other hand. Okay, and the phone in another one. Alright, so this is how we're gonna do it. I'm gonna apply it again, and we're gonna say yes when it's gonna ask us. So let's go ahead and do that. Do you wanna apply that? I'm gonna say yes, and it's gonna do it again, and I'm gonna say yes again, and then the screen will go to 640 by 480. Such a small and such ugly, and now it's going to be upscale, and you're gonna see how the 640 by 480 looks like upscale on 16K UHD is going to be ugly. Okay, so I'm gonna escape this. It's gonna save that, and over here I'm gonna confirm it again. Yes. Let's go ahead and verify it. It should be, yep, normal. What's gonna happen, guys, I'm going to reboot the game. We already applied the settings, so over here I'm gonna say no. I'm gonna reboot the game. So we're gonna refresh the garbage collector for the system RAM and video RAM, so data will be showed correctly at the left top corner. So let me go ahead and do that. This is very important. I'm just gonna restart the game. Here we go. I'm gonna do it every single time when I'm gonna switch the visual settings, because this game engine is actually required that, and developers will tell you from time to time if you're gonna go from the lowest settings to the highest settings. It's gonna ask you to restart the game itself. Just because I didn't develop this game, this is what I'm assuming. You gotta do it anyways, just to reboot and refresh the garbage collector for system RAM and video RAM, so it's gonna show you the data correctly at the left top corner. So guys, this is world's record. Don't forget to smash that like button. A lot of time, money, energy is invested, and I'm looking to have your support. Check out my 15,260 x 8640.com for the 16K UHD benchmark, 16K UHD gameplays, 16K video resolution gaming. You don't want to miss that. I'm a pioneer of 16K UHD video resolution, and especially gaming, and I'm sharing the data with you like nobody else does, and my goal is truly show you the truth and value throughout my videos and provide all kind of data and information. Keep that in mind. Alright, so let's go ahead and check out the options. Should be normal. Yep, normal. Everything else is off. Texture filtering still trilinear. So kinda we increase the visuals, but not that much. We increase the level of details, increase the shadows, and increase the texture resolution itself. So it's going to have more pixels without the artificial decreasing the quality of the textures, blur them out, the pixels. Alright, that's beauty. Do you want to apply? No, because it's going to apply 640 by 480 pixels. I'm going to show you how it's going to look like. It's going to look like ugly. Let's go ahead and test it now. And I'm going to refresh the average frame rates with the short keys. This is the most beautiful Batman game that is available out of the 4 Batman series games. Who knows, maybe I'm going to, guys, record this Batman Arkham Knight for you in 16K UHD video resolution walkthrough with the RTX 4090 video card, or maybe with the RTX 5090 or RTX 5090 Ti video card in 60 FPS average. I believe the Blackwell GPU architecture by Nvidia, the flagship video card, I believe will show in 16K video resolution about 50-60 FPS average, but we're going to find out because single Titan RTX showing 10 FPS, as you can see, right? So RTX 3090 video card is twice performance as Titan RTX, exactly twice as minimum, while RTX 3090 Ti video card is 2.3 times, like a 2 Titan RTX and quarter, almost like 1/3 additional on top. So RTX 4090 video card, which is Nvidia EDA GPU architecture, 2 generation from Nvidia Turing GPU architecture, that is Titan RTX. That video card is supposed to be 4 times faster than Titan RTX because it's twice faster when fully utilized than RTX 3090 video card. Especially, I saw it through the Blender 3D while using the CUDA cores. The raw power is 4 times over the Titan RTX or 2 times over the RTX 3090 video card. But just because it's going to bottleneck in PC games through the CPU is not fast enough, doesn't have instruction per clock enough to handle the RTX 4090 video card, not even RTX 4090 Ti video card, all those CUDA cores in real time. So it's not going to be utilized at 100% or 99%. So it's kind of slowing down and showing in PC games about 3x performance over single Titan RTX, or about 1.7 times performance over the RTX 3090 video card, but should be 2 times performance over the RTX 3090 video card. So I'm assuming that maybe 2 more generation Intel CPU will unlock the full potential of just the RTX 4090 video card. So you can imagine the RTX 5090 video card is not going to be fully showing its potential because we're going to be bottlenecked through the CPU. And right now we are not bottlenecked through the CPU because single Titan RTX utilized at 100%. So we are utilizing every single CUDA core available on our Nvidia TU102 GPU, which is total of 4608 CUDA cores, or 256 CUDA core more than an Nvidia RTX 2080 Ti video card. But RTX 2080 Ti video card can't even load this Batman Arkham Knight game in 16K UHD video resolution because, as you can see right now, video RAM utilization is almost 24,000 megabytes, which is almost 24 gigabytes. System RAM utilization under 16K UHD should be around 16,000 megabytes. So if you're gonna see system RAM utilization will go above 18,000 megabytes, that's a clear sign that we are offloading about 2 gigabytes of video RAM into the system RAM. So it's offloading after the level a second cache into the video RAM, but instead of video RAM it's passing by the Nvidia driver into the system RAM, and you saw system RAM is just 50 gigabytes per second bandwidth, which is 50,000 megabytes per second bandwidth as best capabilities, while the video RAM bandwidth right now is 780 gigabytes per second, which is 14 times faster in terms of the bandwidth. We can push 14 times per second more through the video RAM than through the system RAM, so keep that in mind. Alright, minimum FPS 7, maximum FPS 15, average FPS 10. Not bad, almost the same FPS. This is with the normal textures, normal visual details, and normal shadow details. Okay, same almost as low, doesn't matter for the Nvidia Titan RTX video card or Nvidia Turing GPU architecture flagship. Alright, let's go ahead and switch, guys, and let's go ahead and now I'm going to go maxed out, okay, but I'm not going to use anti-aliasing yet, but we're gonna max out also the textural filtering. So texture resolution high, which is the maximum, shadow quality high, which is the maximum, level of details high, which is the maximum amount of triangles per 3D objects, 3D models, 3D primitives, whatever you want to call it, or triangles or the polygons. It depends on the game engine, whatever the game developers decided to call it. So everything will be high. Textual filtering will be 16x. AF16x. Let me go ahead and switch it. So not 4 times anisotropic, but 16 times anisotropic. Alright, I'm going to accept that. I'm going to say apply. And I'm going to say yes. And apply that. Gonna take some time, and we gotta reboot the game. So now it's applied and it's showing the resolution. Let me say yes here. It's showing the resolution 640 by 480. This is how it look like when you're going upscale to 16K UHD. So you saw the difference, 16K UHD native versus the 640 by 480 upscale through the Nvidia driver, but not through the DLSS, but upscale natively. And this is how ugly it is. Let me fix that. So we're gonna reboot it anyways. In the end of this video, I'm gonna include an extra bonus, but don't forget to smash that like button. A lot of people was asking me. I'm gonna bench it to find out the raw performance of the CPU in this under this particular benchmark, so we're gonna use it in the future as well while we're gonna test the CPUs. But let me escape that. We're gonna escape that, exit that, yes, and I'm gonna change, guys, the, let me show it to you. So what's going to happen, you're gonna go to documents, you're gonna find the folder WB space games, and inside of that folder there's going to be another folder Batman space Arkham space Knight. And inside of that folder you're gonna allocate GFX settings. Make sure that your cloud saving is disabled under the Steam if you're doing it on a Steam or under any game clients that you're using it. Disable the cloud saving, so it's gonna save on the local storage, and this is how it's going to be under the local storage for the game Batman Arkham Knight. So you're gonna open up the GFX settings .Batman Arkham Knight.xml, right click on it and say edit, and it's going to open the notepad for me, or select to open in notepad. Let me go ahead, I'm gonna go ahead and do it. Okay, and in the middle you're gonna allocate, it's gonna say resolution X value 640 for me. For you it could be saying different if you're not gonna set above 10K video resolution, because the maximum artificial lock in the Batman Arkham Knight game is 10K video resolution. I'm going to demonstrate it for you actually. So over here you're gonna say 15,360. This is going to be the width, and under the resolution Y, instead of 480, I'm gonna say 8640. Okay, I'm gonna click file and save. I'm gonna save it. and I'm gonna run it in Steam. I'm gonna click play under the Steam game client. The user interface on the Steam game client can change, but this is what it is. Game is going to load up into the 640 by 480 first. Somehow it's somewhere it's saving this ugly information. Okay, but I'm gonna show you how we're gonna tweak it out and how we're gonna change it. Look how big the font size, this is unbelievable, and how big the Nvidia ShadowPlay recording thing. Just tiny green dot under 16K UHD in the right bottom corner in my case. So you're gonna load up the profile and then you're gonna go to the option. Let me show you how to tweak it. So they created the function that locking the Batman Arkham Knight game into maximum 10K video resolution, but let me show you. And if it's above 10K video resolution, it's gonna go to 640 by 480 automatically by its functions that they wrote, or class, whatever the language they used. This is, I'm telling you this as a software developer, game developer, because I have some experience to it. So but I knew that they didn't figure out all kind of situation for the user, for the gamer, and the situation will be, if I'm going to switch, right now it says window no border from window with border, and I'm gonna click escape. It's gonna say settings have changed. Do you want to apply the settings? I'm gonna say no. Nope, not that. Sorry about that. So Windows no border. Instead of Windows no border, I'm gonna go Windows with border. Now instead of escape, you don't want to click escape, you want to click apply. So first thing what it does, it applies every single settings except the resolution. Apply the resolution. Do you want to apply those settings? I'm gonna say no. And I'm gonna escape. Do you want to apply those settings? I'm gonna say no again. No, it doesn't work. Hold on. Alright, let's change the resolution. It's gonna work out if I'm gonna change the resolution. So 640 by 480 is kind of hard to see, it's pixelated. I'm gonna switch to 720 by 480, whatever, right? Then I'm gonna say escape, and now it's going to apply the resolution. It says, do you want to apply the resolution? I'm gonna say no. Nope, it doesn't do that. Come on, I figured this out one. Let's go ahead and do the 10K video resolution as maximum resolution. Let me show you something. Alright, 10K resolution is maximum resolution, and now I'm gonna press enter. So, and it's skipping. So this is just the same thing as Batman Arkham Origin, guys. 10,240 by 5,760. This is artificial lock resolution. So I'm gonna go ahead and click apply. Do you wanna apply the settings? I'm gonna say yes. And it's gonna apply it, and now are you sure? And I'm gonna say no, and check it out. It's gonna back to 640 by 480. So what I'm gonna do now, I'm gonna keep that 640 by 480. I'm gonna say Windows no border. I'm gonna say Windows with border. I'm gonna apply this. It's gonna say, do you wanna apply? I'm gonna say yes. I'm gonna apply that, and it's gonna bring that resolution 640 by 480. See, like small like it is. And then I'm gonna say no, I don't want to apply it, and it's gonna bring that 16K video resolution, but it doesn't do it because I did a mistake. So what I'm gonna do, I'm gonna say save everything. Okay, let me make sure that no border. Okay, and I'm gonna quit. I'm gonna quit the game. So I understand how it's working now. I'm gonna click exit. I'm gonna change to 16K video resolution. It's already changed in this profile of this file. It changed that. I'm gonna save it again the way it is, like this. Save it, and I'm gonna start the game again. Now I'm gonna switch to window with border. I'm gonna say save the settings. It's gonna save the settings, every single setting except the resolution, just like in Batman Arkham Origin game. Then it's gonna tell us, but do you like the resolution? Do you wanna say yes or no? I'm gonna say no. I'm gonna click escape button, and it's gonna load up that graphics XML file with a 16K video resolution file. 16K video resolution X and Y as I just saved. Check it out. Let me show it to you. You will understand that. So this is how you tricking this game engine and avoiding this artificial lock, because they didn't figure out what if user will click no, and because they asking twice about the saving settings. Number one, it's saving everything except the resolution, and number two, it's saving everything except the resolution plus the resolution on top. So if you're gonna click no, it's going to save everything except the resolution, this presets, on second time, and it's gonna bring the resolution on top of it the way it was, just like in Batman Arkham Origin. Go ahead and watch that video, Batman Arkham Origin in 16K UHD video resolution. I figured out how to do it because it doesn't support above 10K video resolution as well, but I figured out. And but Titan RTX is the first video card anyway that can run Batman Arkham Origin or Batman Arkham Knight in 16K UHD video resolution anyways. So over here I'm gonna switch it to window with border. Okay, I'm gonna click apply here. It's gonna apply everything. Check it out. Apply here. I'm gonna click yes. It's gonna bring that window, and now I'm gonna click escape. It's supposed to take that, and it's not taking it. Okay. Let me double check the file. Why it's not taking it? I don't want it. It's supposed to taking it, but it doesn't want to taking it. This is strange. Let me take the file, because without Nvidia Shadow Play recording it was taking it. Maybe just because it's recorded. Oh, I didn't save the file. I didn't save this file. I pressed the wrong button and said, do you want to save it? Are you sure? Let me make sure that I save the file. Check it out. I pressed the wrong button here. See, I gotta overwrite the file, but I gotta press something else. I gotta press it like that. So small, and I'm sitting a little bit far away from, and I cannot see. Alright, now it's gonna do it, guys, because I didn't save the file. I saved the file at 640 by 480, and I didn't save this settings at 15,360 on width and on 8,640 on height. Now it's gonna do it, guys. So this method that I showed you, it's going to work out now, and it doesn't matter if I'm recording with Nvidia Shadow Play or not throughout this particular approach. Yeah, so you learn something. You learn how to fool it to go above 10K video resolution. I just shared the tips with you and experience and knowledge. So don't forget to smash that like button. Anyways, graphic options, same deal, guys. Window, no border, window with border. Okay, now I'm gonna say apply. It's gonna bring the 640 by 480 windowed mode. I'm gonna say yes here, but then are you sure you want to keep the resolution? I'm gonna say escape button on the keyboard. Check it out. Now it's gonna take some time. Now it's working. It's gonna take some time, about like 10 seconds, and it's gonna load up that 16K UHD video resolution, that and that graphics.xml file, and it's gonna bring it. It takes like 10 seconds, something like that, and exactly, yep. Even if it's saying 640 by 480, you can see everything is so nice and so solid and so sharp. It is what it is. And when I enable the display information system overlay, it's so sharp, and it's exactly designed, the size of it designed for 16K UHD VR, indeed, pixel per pixel, natively in 16K UHD video resolution. Okay, you can zoom in, zoom out, or do all of this. I'm not gonna do it throughout this video. I already done that. For those naysayers, go ahead as again visit my Crisis 2 in 16K UHD video resolution benchmark video on Titan RTX video card. I dedicated all the zoom in, zoom out. I show you everything what you need to know, difference between 16K UHD versus 8K UHD versus 4K UHD versus 1080p. All the information is available over there. So over here now, you want to click escape, It's gonna tell you, do you want to save it? I'm gonna say no, and it's gonna keep that settings, because otherwise if I'm gonna say yes, it's gonna bring that 640 by 480, because it's second time verifying, and it's verifying not about the settings now. Even if it's telling the settings, they did a mistake. They did 2 times verification, but it's verifying about the resolution. First time it's verifying about the settings. Here's the deal, guys. Here's the tip. First time it's verifying about the settings, everything except the visual settings, except the resolution. And second time it's verifying about the resolution. And just like in Batman Arkham Origin. Alright, now I'm going to go ahead and click performance test, and we're gonna test it. This video is going to take a little bit longer than it is. I just forgot the method. I just woke up, guys, and did some business and come back. I didn't warm up in this, and I just loaded up and start recording. But I tested yesterday just to find out if it's runnable or not. It is runnable, so I decided to share with you. Look how beautiful it is. This is maximum possible visuals without the anti-aliasing. This is just unbelievable, guys. If you're gonna zoom in, zoom out here, it's just unbelievable. And I believe that RTX 5090 video card, which is Nvidia Blackwell GPU architecture, will be able to do this in 50 FPS on average single video card. Keep in mind that this game supports SLI, and I'm going to test 2 Titan RTX video cards in 2-way SLI by Nvidia. So go ahead and smash that like button, and I will try to do it tomorrow, or actually today. It will be available on December 31st 2023, just before the New Year 2024. So I'm going to wrap up the whole Batman series in 16K video resolution on the first video card that is capable to run it, which is Titan RTX video card. Alright, this is unbelievable. 10 FPS average. Pick up some high FPS through the menu, like 19 FPS, and created the average, but I just refreshed the average. The second scene about right now is going to show higher FPS. This is, guys, without the anti-aliasing, maximum visuals. And I'm going to enable the anti-aliasing, and we're going to check it out. I don't think that Intel Core i9 9900K capable to squeeze 2 Titan RTX video cards in SLI at 99% per video card per GPU, just like it's squeezing right now Titan RTX GPU at 99-100%, which it should be. That means that 0 CUDA cores are idling, so we're not wasting any CUDA cores. When you're running games, you want to squeeze your GPU at 100%. 99-100% is excellent GPU utilization, while CPU never reach at 100%. Otherwise, you're going to bottleneck through the CPU cores, CPU threads. Do not go above 90% on CPU threads. Even 90% is kind of you better add 2 additional cores to it. Otherwise, there is a possibility that you can lose about a couple FPS decided by the Nvidia driver, that you can bottleneck through the CPU. And the best possible to keep your CPU utilization, overall CPU utilization, below 90%. Right now, overall CPU utilization 9%. The higher resolution, guys, the lower CPU utilization, because CPU is not used a lot throughout the PC games, and a lot of stress and a lot of computing goes on the GPUs. Keep that in mind. And CPU just waiting for the GPU to complete the compilation, and then through the CPU do some tasks, just a couple tasks, but most of the tasks done on a GPU in PC games, or in console games, or on the mobile devices games. GPU does a lot of tasks while rendering 3D real-time graphics. 11 FPS, beautiful, almost the same FPS. This is unbelievable. So I'm assuming, predicting, I didn't test it yet, that 2 Titan RTX in SLI, in 2-way SLI by Nvidia for 2 Titan RTX video cards will do about, not double, should be double, when it's not going to be CPU bottleneck. But I believe that we're going to be CPU bottleneck, because Intel 9 Gen CPU is not enough to handle over 9200 Turing CUDA cores on those summarize on those two Titan RTX video cards. So I'm assuming it's going to be secondary video card will be around 92, maybe 95%, while the first one will be 98, 97, 99. So I'm assuming it's going to be around 18, 17 FPS, but it should be 24 because it should be twice double if it's at 100%. Nvidia SLI is perfect when it's 100% per GPU. Keep that in mind. Throughout my 4-way SLI experience, 3-way SLI experience, and 2-way SLI experience on all kind of different Nvidia GPU architectures. Alright, so we underlined this one: minimum FPS 6, maximum FPS 15, average FPS 10. Beautiful, beautiful. Alright, let's go ahead and enable the anti-aliasing while recording. This is going to be very heavy, and but for Nvidia Turing GPU architecture, such as Titan RTX video card, anti-aliasing in the Batman Arkham Knight is just like candy, chocolate candy. It's gonna chew it like nothing. But let me go ahead and demonstrate it for you. We want a demonstration of that, right? By the way, the game is not pulling correctly the maximum video memory usage. It should be 24,468 megabytes, or maybe 200 megabytes allocated for a system for the Windows. Who knows? Because the GTA 5 pulling about the same information. Anyways, but game developers can pull the wrong data from the wrong classes, or maybe they're correct, who knows. Anyways, anti-aliasing will be all the way on. I don't care about chromatic aberration or film grade. Those type of settings pretty much not going to eat any FPS, but it's going to look it's not gonna look nice. It's gonna look ugly if your FPS is not 25 FPS or above. It's great above 30 FPS. 30 FPS and above to use the chromatic aberration and film grain. Otherwise, it's gonna ruin the pixels anyways. And we're struggling for the maximum quality of the pixels and maximum details, right? So this is what is going to be, guys. All right. So what I'm gonna do now, I'm going to apply that. I'm gonna apply that. I'm gonna say yes here. Do you want to apply the changes? Yes. It's gonna take some time, and it's gonna apply the anti-aliasing and as well as resolution. And then do you want to apply the resolution? I'm gonna say no, but it didn't bring us to the resolution back. So what I'm gonna do, no, it is, it's supposed to bring us to the resolution back. Actually, it is right now. It's in the process of the thinking about it. It brought us actually, but it didn't save the anti-aliasing. So no, I want to say no. So I'm gonna bring back again the oh my goodness, sorry, I smashed the escape button, smashed the wrong button. Let me go to graphic options again. I'm gonna say the anti-aliasing on. If it's going to be the resolution 640 by 480, it's fine. What I'm gonna do, I'm just going to quit the game, and I'm gonna open up the graphics XML file, and I'm gonna edit the resolution there. Let me smash the apply button. Do you want to accept it? Yes. It's gonna bring, do you want to do it? Yes. I'm gonna say yes. Alright, 640 by 480, it's fine, guys. Let's go ahead and get back. I'm gonna exit the game. I'm gonna exit the game anyways, and I'm gonna open up that file. Let me close that because we want to have the anti-aliasing on. And let me edit it again, that graphics file. Remember that file? You're supposed to know already. The GFX settings.Batman Arkham Knight.xml. And I'm going to go ahead and edit in Notepad. Okay, and I'm gonna, in the middle, I'm gonna allocate resolution X and resolution Y. And I'm gonna say 15,360, and resolution Y I'm gonna say 8,640, which is the height. 8640. I'm gonna save that, and the aliasing should be on, but I want to make sure I'm saving this file now, so it's not gonna be any problem. Yep, it's saved. Not save as, but save and play, and let's go ahead and have a look. It's gonna load up 640 by 480, but you already know the trick, how to trick it out. So it's gonna load up this resolution from the graphics.xml file, from this GFX XML file. So this house 640 by 480 upscale. It looks ugly, guys. You can tell. This is the upscale, and this is the native upscale. This is even without the DLSS. Or who knows? Maybe Nvidia through the driver forcing some DLSS. I don't know, but in theory it should be native 640 by 480 that is upscale to feed this 16K UHD video resolution, and it's ugly. You can see it, it's ugly. But maybe Nvidia forcing the DLSS on top through the driver automatically. We never know. I'm not Nvidia driver developer, so only Nvidia knows, the developers or the driver team. Anyways, you learn how to tweak that, so we can see anti-aliasing is on. So you go window, no border, window with border, and then I'm gonna apply. It's gonna say, do you wanna apply? I'm gonna say yes. Then I'm gonna click escape button here. It's gonna take about 10 seconds, and it's gonna load up and bring exactly 16K UHD native. It's gonna pull up that resolution from that gfx.xml file. Takes about 10 seconds, so don't freak out. Your system didn't freeze. 10, maybe 15 seconds. You gotta wait, and yeah, it's gonna bring it up, and everything is ready. Maximum possible visuals. And as again, don't worry about that 640 by 480. Okay, gonna smash that escape button. It's gonna say, do you wanna save it? Gonna say no, because if we're gonna say yes, it's gonna save everything that you already saved plus the resolution and 640 by 480, and we don't want that. Okay, let's go ahead and run the benchmark test. Let me bring the display information system for you. PC performance test, here we go. Video RAM utilization, check it out. System RAM utilization is almost 20,000 megabytes. That means we are floating at least 4,000 megabytes or 4 gigabytes from video RAM into the system RAM. And video RAM is also 20 gigabytes. So it's above 24 gigabytes right now is used. A little bit above 24 gigabytes. So video card with the 32 gigabyte of video RAM will be Gucci here. Running 16K UHD without any overloads at all of the data from the cache second on the GPU into the system RAM instead of video RAM the way it's supposed to. And I believe it decided by the Nvidia driver to avoid any overload of the video RAM. I believe it as a software developer, and to avoid any blue screen, because Windows gonna blue screen. So it's doing it in advance. Actually, it's predicting in advance. And right now, as you can see, system RAM utilization lowered, so we are offloading about 16 gigabytes or 16,000 megabytes is supposed to be our system RAM utilization under 16K UHD at lowest visual preset, and should be stay that way. Everything else should be loaded on the video RAM. So we are floating right now 2 gigabytes, so 20 gigabytes loaded plus 2 gigabytes, 22 gigabytes. So we are still healthy video RAM utilization, but driver doesn't know that, so it's automatically offloaded the data just as a pre-prediction. It's predicted, pre-thinking in advance, and just to make sure we're not going to crash. So after 20 gigabytes, when Titan RTX, this is what I found out through my 16K UHD video resolution experience and 16K gaming. After 20,000 megabytes loaded on Titan RTX, and it's so heavy in the game, Nvidia driver is predicting and start offloading some data, not necessary data, not data that's going to slow you down by a lot, but maybe slow you down by a couple FPS, but already offloading some data into the system RAM, because it can see it's 4 gigabytes to go. I think it's based on percentage. When like 10% to go, in our case it's like a little bit more than 10%, but when it see 10% to go or 20% to go, it start uploading not necessary data that is not going to slow you down in terms of the FPS, but instead of video RAM, it's already loading into the system RAM. DDR5 of course will be faster than DDR4 and will be less and creating a lot of nanoseconds, not nanoseconds, but ms, milliseconds latency delay. As you can see at the left up corner, there's a milliseconds right there. Okay, and that milliseconds is the latency delay before every single frame is rendered. So it's 100 milliseconds right now, 100 ms by that FPS at the left up corner. So comfortable gameplay below 10 milliseconds. Above 10 milliseconds already a little bit stuttering. You can feel it, a little bit lagging. Above 20 milliseconds it's kind of lagging, you can feel it. So Nvidia SLI, it's not stuttering, it's just the high latency delay that was creating that stuttering kind of effect in your brain, psychological. Because when people was running Nvidia SLI on 1080p, they do not understand that they were bottlenecked through the CPU. They did not understand that, and most likely the latency was like above 20 milliseconds, and they were saying it's a stuttering at those moments, was even above 20 milliseconds when those type of moments happened. But the problem, people wasn't smart enough like me. From the beginning of my YouTube channel, I was showing you the milliseconds latency delay besides the FPS, but those people was only showing you the FPS, but they never was showing you the milliseconds latency delay. But latency delay is also crucial, guys, keep that in mind. So as again, below 10 milliseconds comfortable latency delay, especially 5 milliseconds amazing gameplay status, comfortable. But above 10 milliseconds already you can feel a little bit stuttering, especially above 20 milliseconds you can already feel the lag and stuttering, keep that in mind. So the lower milliseconds, the better gameplay experience, and the higher FPS, frames per second, the better game experience. Okay, the higher milliseconds, the baddest game experience, not good. Alright, hopefully I explained it well. So maximum visuals including the anti-aliasing, but the game works by Nvidia is disabled completely, which is unable to be able to run Titan RTX while using the Nvidia Shadowplay with this driver. What I find out, no matter what kind of resolution we're talking about, go ahead and check out my 4K, 8K UHD benchmarks in Batman Arkham Knight game, as again over the UHDking.com. You're gonna find out why. But minimum FPS 6, maximum FPS 14, and average FPS 9. This is a great result. Two Titan RTX video cards, I'm assuming maximum will be around 19 FPS, maybe 20 FPS. Minimum will be around 10, and average FPS I'm predicting will be around 15 FPS. I didn't test it yet, but we're going to find out. And smash that like button, subscribe me, positive comments, share it with your friends, guys. And most likely I'm going to share video on two Titan RTXs and SLI for those people who's curious, for those Nvidia fans, for those gamers, for those PC hardware enthusiasts, system engineers. I'm gonna share, guys, with you the information before the new year 2024, before the January 1st 2024. But this is my prediction. Beautiful visuals. When it comes to 16K UHD video resolution, you want to look at the distance, and at the distance when you're running 4K UHD, everything will be blurred out, but over here everything is still rock and roll. I cannot zoom in, because if I'm gonna zoom in, everything will be, yeah, it's gonna get back, yeah. But if I would be zoom in, those pixels are there, believe me, guys, and everything is just solid and beautiful. Alright, so what I'm gonna do now, I'm going to run the test in minimum visual preset. This is going to be the bonus, but 640 by 480, just to find out the performance of this CPU, which is the Intel 9 Gen flagship for the PC games, which is i9-9900K, highly overclocked from 3.6 gigahertz per every single core to 5.1 gigahertz. This is a lot, guys. We at least received over 10% performance, healthy performance, raw performance, and this CPU right now when it's running 5.2 gigahertz is faster than 10,900K running stock. So I'm gonna lower everything what is possible to the lowest possible visual preset, and here we go. And we're gonna save it like that, and I'm gonna execute it, and we're gonna run it. And actually, let me go ahead and apply that, and I'm gonna apply that again, and I'm gonna reboot the game. Apply. It's gonna bring to that windowed mode. We're gonna apply again. Here we go. I'm gonna say yes again. It's borderless. Escape. Escape. I just want to change the size of the overlay display information system so you can see exactly what it is, and I'm just gonna test it for you guys. You're gonna see that the CPU bottleneck a lot. It's going to be FPS same as 1080p, but let me go ahead and execute that. As again, this is an extra bonus. Don't forget to smash that like button. A lot of time, money, energy is invested. And support me, guys. Visit my sponsors, watch my sponsors, click on my sponsors. So I'm gonna collect those pennies and invest back into you guys throughout my games giveaways. I'm always doing it throughout the holidays. I gave away about 10 games throughout this Christmas and 2023 all the way till New Year. So a lot of people won the games. Hopefully they happy. Oops. Hold on. So we can see the whole deal right now. See how big that Steam community while under 16K UHD was just tiny. Alright guys, it's gonna keep moving. Hopefully you can see everything is so pixelated, but I know it's going to blur out for you a little bit. Maybe you're gonna see it better. It's gonna kind of blur through the re-encoding of the YouTube of this 8K UHD video resolution. Will be kind of anti-alias those edges, those ugliness. But anyways, this is the presets. You already know everything lowest possible visual preset. Alright, and performance test, and I'm gonna refresh my averages. Let's go ahead and have a look. So about 100 FPS in 4K HD, so 1080p will be above 200 FPS. This one should be like way above 400 FPS, and it's not. The latency below 5 milliseconds, below 3 milliseconds. That's a crazy experience to play like that. But it's looked like a Doom all the way back in 1992. So pixelated. So you can see the difference, guys, in resolution. 640 by 480 versus 16K UHD. Over here you see the pixels. Over there you see beautiful details. Because this is what resolution does. For those people who didn't take the mathematics class in high school, middle school, and physics, that doesn't understand the basics on the planet Earth, this is what it is, guys. And computer science is pretty much introduction of the mathematics plus the physics on top of some elements of the physics. Those two mathematics and physics are, and chemistry is pretty much is ruling the planet Earth, not the woke ideas that you're watching of those copycats YouTubers that copying each other. Here's, guys, the FPS, same as I recorded, but minimum FPS 178. Hopefully you can see it. Maximum FPS 325 FPS. And average FPS 236. So we're bottlenecked through the CPU a lot. So hopefully the 13 gen or 14 gen Intel CPUs can squeeze out of the Titan RTX in SLI. in 16K UHD at 100% per GPU, but I have some doubts that i9 9900K, even overclock at 5.2 or 5.3 gigahertz, can squeeze two Titan RTX video cards per GPU at 100%, at 99-100%, as we saw was squeezing single Titan RTX in 16K UHD. I think it's not going to be enough instruction per clock on the CPU on the i9 9900K. Maybe on 13 gen or 14 gen, but we're going to find out on my new system in 2024, Mozilla PC version 6. So stay tuned, guys, and I'm wrapping up with the Titan RTX video cards, as you can see, with the Turing GPU architecture. Hopefully, guys, you enjoyed that. This was an amazing video. I enjoy it a lot. For me, as computer scientist, technologist, hopefully you learn it a lot. As again, I provide a lot of value to one as well as world record today throughout this video in December 30th, 2023, before the new year of 2024. Don't forget to smash that like button, guys. By the way, as again, on the background, this is my system with the Corsair H150i Pro water cooler all-in-one system AIO on a CPU with the liquid metal thermal compound paste by Thermal Grizzly. Titan RTX running, as you can see, Founders Edition dual fan design, kind of noisy. Check out, guys, my projects. My projects was amazing, as well as 15,060x8640.com or iplay16k.com. It is going to be dedicated to 16K UHD gameplay, 16K UHD gaming, 16K UHD benchmarks that you don't want to miss. Also check out UHDking.com or UHDking.com with the one. Yeah, looking forward for it, guys. So hopefully you got a great Merry Christmas. If not, I wish you a great Happy New Year 2024. Thank you so much for watching. Thank you so much for your support, guys. Check out my YouTube channel throughout the holidays. As always, I will try to provide some values to you while collecting those pennies through those ads that you're gonna watch. Please watch those ads and invest back into you and into more resources throughout my computer science and technologies. So I'm gonna demonstrate to you more ideas in the future, and hopefully in 2024 I'm gonna show you over 240 inches 16K UHD array made up out of the 4 8K UHD screens. You're gonna see a lot of copycats will be copying me, but you know who was the first pioneer, who was the first YouTuber that showed you 16K UHD gameplay, 16K gaming? It was UHD King. I play 4K, AK, I play 8K, AK, I play 16K, and you know exactly why UHD King, why I play 16K. Till the next time.